All right. So, thank you all for coming. Hopefully you enjoy this talk and you're not just here for the air conditioning because it's hot outside. But first of all, I'd like to thank everyone at RVAsec who put this together, the volunteers, the contributors, organizers. This is an awesome conference. First time I've been here. We're usually from Maryland, so we kind of do all the conferences in that local atmosphere. But this is by far had the coolest badges I've ever seen and some sweet fanny packs. So I'm looking forward to this. I walk my dog all the time, Miles, and now I'm going to wear this. And people are just going to look at me, but I don't care. So thank you all very much. And this is a great talk and event, so appreciate it. So on behalf of BreakPoint Labs, my name is Zack Meyers. This is Andrew McNicol. And today we're basically going to be talking to you about how to go beyond automated testing. And automated testing to us is, say you run a vulnerability scan. Okay, that's great and all, but that's just a starting point. How can we go beyond automated scan and a report that we get from an automated tool and do some manual testing and essentially find and enumerate additional vulnerabilities and break into stuff that's internet facing? So that's pretty much what we're going to talk about today. Here's a quick agenda. I'm not going to bore you to death and read each bullet, so feel free to read it if you like. But essentially, we're going to go over our methodologies as external assessments. We're going to go into some really good examples and use cases of how we do manual testing and we find additional vulnerabilities. And then we're going to kind of give you some useful links and trainings at the end so you can take away some stuff here. So, real quick, I'm Zach. This is Andrew. You can find us on Twitter. There's our handles right there. We're essentially security geeks at heart. That's what we are. We're red teamers at BreakPoint Labs. We're a small business in the Virginia, Maryland, D.C. area. You can find our Twitter handle there, 0xCC Labs. We're also, in our free time, we're not wearing our day job hats. We have a blog and podcast that we contribute to called Primal Security. So feel free to give that a Google. There's a lot of good blogs. We do a monthly podcast, and we also just love to give back to the community and share things. So you can find us there at PrimalSec. We're certification junkies. We have a lot of offensive security focused certs and SAN certs. We like to code, do scripts in Python. Love capture the flag events. I know they have a great one going on here. We love to learn things all the time. Everything's changing. This job and this atmosphere we're in, we're always learning something new. It's adapting. So it's always good to be in the know and learn new tools and techniques and procedures. And we also like long walks on the beach and by the pier. And speaking of which, if you enjoy that as well and you live in Maryland, I'm a co-organizer of a local meetup group on meetup.com called NAPSEC. It's in Annapolis. We usually meet downtown Annapolis once a month. It's a networking event for InfoSec people. So feel free to check it out. It's just a happy hour kind of atmosphere. You talk, meet new people, and we're on meetup.com. So feel free to check it out. So overview of this talk. The goal of this is to basically share our experiences with external assessments and basically anything that's internet facing. What's the motivation of this talk? I'll be honest with you, it's frustration. And the real reason of the frustration is how many times have you heard this question? Whether it's from a manager or from a coworker or from whatever it may be. Is the scan done? Have you scanned us? When's the last time we had a scan? Are we compliant? Those are the questions we get asked all the time as security professionals. And the thing that with that is, scanners are great, automated tools are great, but they're a starting point. They're not the end point. And that's the goal of this talk, is to show you the real power of that human validation, human review, and human interaction with these applications. So automated testing, to us, it's running a vulnerability scanner in this talk, okay? Manual testing is everything else you do beyond the scope of that scan, whether it's the false positive reduction or it's actually trying to find and enumerate other things and think like an adversary. So according to a Department of Homeland Security report that recently came out, they stated that 67% of high-impact vulnerabilities actually were found via manual testing and not by an automated vulnerability scanner. So that's a pretty cool fact, and I always like to land that point. So how do we go beyond an automated scan? Well, first we have to have the mindset. And the mindset is essentially you're going to fail. As a pen tester, you're going to fail 1,000 more times than you're going to win. And you always have to keep that mindset and continue to try and keep trying. And once you have that mindset and you got everything going, you want to move into this recon and mapping phase with external assessments. You want to find systems. You want to find that content that maybe an automated tool may miss, because all you're doing is pointing at a URL. You want to also then run the appropriate tool for the job, meaning you can run these commercial tools, your Acunetics, your Burp Suite, your HP Web Inspect, but sometimes if you enumerate a certain technology, you may want to run a custom, more oriented scanner or tool, like a WP scan or a Joom scan. It's open source, because that's the technology that's powering the site. Then we really get into the manual testing, and this is what we're harping on here. You want to identify and understand all areas that we can pass user input, and we want to fuzz the applications. We want to research the versions, if we can enumerate them, and the technologies that we enumerate, and sometimes it's just a simple Google and go, Joomla version exploit-db. Not that bad, but that's the truth. We can combine all these different things, and we want to take findings that we find from these automated tools. Sometimes tools will say, all right, there's a low finding here, a low finding here, low finding here, but we can bridge them together to make something that's actually a critical thing and maybe can compromise the site. We want to remove the false positives. We all do that. And then we also want to think, why did the developer make this, this feature for this application? And how can we abuse it? Let's have that adversary mindset. And at the end, which we all dread as testers, we have to put it all in a report and take all the method to our madness and present it to everyone and basically convey the business impact. So with every single assessment, you want to have a methodology. A solid methodology is good from a technical and business perspective. You don't need to marry the methodology, meaning you don't need to go in like sequential steps. You can always jump back and forth. And we'll kind of cover that in a little bit, but say you're doing your reconnaissance, then you do your mapping, you run an automated tool, and while you're doing your manual testing, you find additional things, new things. You can go back to recon. You can do recon throughout the entire assessment. Always keep that in mind. You don't have to go by a checklist. Checklists are good though. And checklists also do help make sure you don't miss things. So we use them. A lot of people should use them just to make sure that you cover the masses and the attack surface of what you're going against. Here's some great methodologies that are open source you can find on the internet. You can just click on these when you see our slideshow online. And we honestly believe that with every methodology, you not only want to have that automated aspect, because everyone does it, but you want to have this manual testing. And we're going to go over some great use cases in a little bit. Here's, from our point of view, our methodology we use from an external internet-facing perspective. We do the planning and scoping. That's essentially your rules of engagement. We'll get into all this in more detail. Reconnaissance, mapping, automated testing, followed by manual testing, or during the automated testing, because tools run for a while. And then it wraps up with that reporting. And it's also nice to do some icing on the cake. Offer remediation support. Sometimes they'll say we fixed something, but really they haven't. So it's nice to close the gaps. So before we jump into the rules of engagement, we as testers nowadays have to basically have not only the hard skills to do the work, we have to have the soft skills as well. And the thing we also have to do is just be confident and convey everything that we found in as much detail as we can in the report. And know that we are going to fail many more times than we're going to succeed, but that's a part of playing, the adversary, essentially. So when we go to planning, we want to understand the customer's goals. What keeps them up at night? That's the main question. And we're going to establish the scope, which is the what, establish the rules of engagement, the how, set up communication channels and the time frame, being the who and the when, and we also don't want to get caught up in terms. To me and you, it may be different, and anyone. You hear the word vulnerability scanning, vulnerability assessment, pen testing. It's kind of a thing where it's always defined by your own thing. And you want to basically establish, what are you looking for here? An in-depth vulnerability assessment that could borderline become more of a pen test, or do you just want me to run an automated vulnerability scanner, such as a Nessus or a commercial tool, and just give you the output and maybe remove the false positives? So find out the level of effort, because it's different. And figure out what the company cares about most. Is it the confidentiality, availability, or integrity of the data? That's truly important because sometimes if it's availability, DOS is off the table. So you got to keep that in mind. You don't want to piss them off and DOS their stuff. So as we do this, I like this, and this is a great thing. I like visuals. I've always been like an artsy kind of guy. So it's nice to have this, essentially creating a mind map. And you can find this open source tool called XMind. And while you're doing your reconnaissance and your mapping and you're meeting with the organization, you can basically say, here's your org. Here's all your systems, whatever you want, however you want to organize it. Kind of gives you a nice visual of what you're up against and what you're doing and how you map everything out. And then you can put findings connected to these systems as you find them. And it gives you that visual rather than just a spreadsheet or a Word doc. This is a nice thing. So take it for what it's worth. Try mind map out if you want to do. All right, and Andrew?
Thanks, Zach. So moving on to, we're going to kind of walk you guys through sort of our methodology, almost through like a pseudo hold your hand through a pen test, so to speak. So we're going to start with Reconnaissance. Zach covered the planning and the scoping. Now the customer says go. So the goal here is, given a company name, how can you figure out their footprint? So if somebody said google.com and said go, how can you actually figure out their infrastructure? And you can do that in a lot of ways. Here are some of the high-level ways that we go through, and we're going to kind of talk about each of these individually. But essentially, you're going to start out with doing Google search and doing some basic IP and domain enumeration, using some DNS tools, dig, whois, etc. Then system enumeration, we're going to talk about that. Subdomain enumeration is very important. Tech stack enumeration, OSINT, we're going to go into each of these in another slide here. So starting out with system enumeration. One of the things that we really like to do, and this is actually something I do during the scoping phase, is I leverage Shodan and Census. By show of hands, has anybody used these, familiar with Shodan and Census? All right, well, if you haven't, I've just changed your life. These are awesome. These are awesome. They're essentially third parties. They scan the internet and they host the data for you, so you can do some queries. They have APIs and Python modules, and also web interfaces too, so if you're not Python friendly. But this is a little Python script you see on the screen here that's searching Shodan just for a host name google.com, and it's going to give me everything that it knows about with Google. So if I'm going for against a target customer, they'll say, okay, I want to get an idea of how long this will take. This is a great way I can find out in seconds. I can say, okay, 85,000 systems, it's going to take me a little longer than 5. So you can get an idea, a quick bit of data there. And Census is the same kind of thing. Census is free. Shodan, you have to pay. They have some free, but also paid for subscription, but Census is completely free. So definitely check them out. And then after we've gone through here, and we're actually starting to do the active probing, we're going to use Maskin and Nmap. I'm sure everybody here has heard of Nmap. It's a great tool, network probing, and a lot more functionality with the scripting engine, but you may not be as familiar with Maskin. So to give you some idea, if we were to run Nmap across a /16 Cedar range, looking for some common web ports, turning name resolution off, that might take 30 or 40 minutes. With Maskin, we're talking about 30 or 40 seconds. So it's actually really cool from an internet perspective when you're doing scans across large scopes. It can give you some data quickly to go with. Then we move into subdomain enumeration. So the previous slide, we found like our IPs that are up, our systems that are up. And this is getting an idea of finding out all the subdomains that are tied back to that target organization. So if we take, for example, google.com, a subdomain would be support.google.com or helpdesk.google.com. And finding out all these subdomains is very critical as we move into our testing, because you can't just judge an IP by its IP. We'll talk about that in another slide here. If you're new to subdomain enumeration, Jason Haddix wrote a really cool script that automates Recon-ng for this very task. It's called enumall.sh. You can essentially just run it, and it pulls out subdomains and throws it to a CSV file. You do have to kind of configure Recon-ng, but it's not too bad. CRT.sh looks at X509 certificates and indexes them. You can look at the common name to pull out subdomains. A lot of cool little tricks there. But this is a very important step that your tools aren't going to do for you. The next thing is we've got our subdomains, we've got our system, we're starting to build out this scope. We want to get the tech stack. We want to understand what kind of technologies we're working with. And we really like WhatWeb. It's a command line Ruby script. You essentially give it a list of URLs. And it will go out and tell you, it'll make a head request or get request, and it'll tell you the technology that's there in a single greppable line. So very friendly to, grep, sed, awk-foo. You can basically grep and say, where's, grep Cold Fusion, grep, Joomla, WordPress, what have you, and it grabs the title. So it can be a great starting point. If you're looking at thousands of applications, this can be like starting to get some idea there. Wappalizer is a browser plugin that will tell you in your address bar the tech stack as you're navigating to the actual website. So you can actually click there and say, okay, cool, Drupal, awesome. And it just gives you a quick visual. It's a nice little tool to help you out. Eyewitness is a very cool tool, and it might not be, the power might not be obvious to you if you haven't dealt with a pen test that has like thousands of apps in it. So essentially it's a Python script. You give it a list of URLs, and it will break down the headers and a quick screenshot for you and an HTML report. So if you're talking about a couple hundred URLs, pulling those up in your address bar in your browser, it's going to crash. But this is a great way to get a snapshot from a high level, take a look and just see all your scope. Where's the default IIS? Where's the default Tomcat? And start to build that map and have a visual, and you can talk to your guys. You look at the Tomcat app, and it's just a much easier way to kind of see things from a high level. Then OSINT, which can mean a lot of different things to different people in the context of this talk, and what we see OSINT as is you kind of look at it in these ways. We like to find out, is the customer already compromised? Again, it's kind of something your tool's not going to do for you, and that can be pretty big. We've seen instances recently with a customer that on Twitter that bad guys were talking about SQL injection in one of their stuff, and we were on the assessment, and that really changed the way we did our assessment, but it added value to the customer because now they're like, oh man, it's kind of switching incident response modes here. But you might find things on maybe, they've had password dumps and paste bin, things like that, and you can let them know, and they're not too worried about it, but they might be cool to reuse later in the test. But that's important. We also are looking for like usernames and going to social media to learn about the users of the system, because later on we go to brute forcing and hammer our way into the app. Those are going to be really important. Another funny thing is just postings on Stack Overflow or any type of help forum, Cisco ASA configs landing on the help forum. Those kind of things could be interesting. It might just be a good FYI to the customer saying, hey, change your policy or make sure you talk to this guy. And then looking for source code. So, GitHub, Pastebin, can you find source code? That's going to be helpful for you later. They might be using some application that you can, pull source down and do some analysis there. So after we finished our reconnaissance, the next phase we've got our list of apps and technology. I know this is my Cold Fusion Exchange server. I've got some idea of what's going on here, and now we're going to map that technology to figure out the next level of what's actually there. So mapping is key, and in my opinion, automated tools do an okay job at this. They spider, and spidering is essentially looking at what it has references to it in the code and building out that sitemap for you. It's very easy to do. In your burp, you'll right-click spider with a screenshot of that, and web inspect, Academics, they're going to spider for you by default. But what tools don't do a great job of is the unlinked content enumeration. We're going to show you how we do that. You're going to get a lot of wins if you're going up against a large amount of web apps. Unlinked content enumeration is a gold mine. Remember when I was talking about don't judge a system by its IP? This is critical because a lot of times our tools, you give it a list of targets, right? So if you give it a list of IPs or even the URLs based on the IP, you might be missing a lot of stuff. Because with virtual hosting, you could have a lot of apps sitting on one IP address that you have to reference the domain name to actually get the content. You might be seeing a default IIS page on the web root and it doesn't redirect to anything. You're going to see that a lot, actually. And you might think there's nothing here. I guess this is boring. Maybe I'll find something interesting like Poodle. But be wary that there might be a directory, an application living in a directory that's not automatically referenced by the root. So you're going to have to do that unlinked content enumeration to really pull it out. So how do you map an application? This is Burp Suite. I'm sure if you've done any bit of pen testing or security assessments, you've probably used it. They have a free version and a pro version. It's an awesome tool. Essentially what you can do is add a particular URL to your scope, and you'll see it in the window there, and you can right-click and spider. It can take a while. Spidering, in fact, can take apps down. Be mindful of that. If the app's really sensitive, that could actually hurt it, and you might have to just manually spider by using the app in your browser. But this is essentially spidering. It's going to crawl and go to all the linked content on the application. Not a big deal there, not hard to do. The unlinked content piece of it is where you're going to get a lot of wins. That's the treasure chest with Zelda, big Zelda fan. So we like to use Burp's Intruder for that. It's got a lot of cool features and a lot of cool control to automate requests rapid fire. I use a sniper a lot for that particular resource, and I just identify, set the resource I'm requesting as the variable, and then I go through a bunch of word lists. Now these word lists are awesome. Sec list is a really good collection of all common word lists for fuzzing, password dumps, web content, DNS stuff, and it's run by Daniel Meisler and Jason Haddix. If you leave here today and you're going to go to an application assessment, you take one thing away from this talk, run the RAF lists against it. Like seriously, there's these lists called RAF lists, and they're in this particular GitHub project. If you run the RAF list against an application, you're going to find interesting stuff that would have otherwise been missed. I can promise you that. And there might be some other techniques here, like using Durbuster is good. That's still a good tool. I personally like to use Intruder, but that's, other things. There's also Burp's Pro feature, Discover Content, that dynamically builds unlinked content for you. So if you have the Pro version, it's on like 350. That's a really cool resource as well.
And once you've done that reconnaissance and that mapping, this is kind of like you've gotten that clear picture, you've defined the road of linked and unlinked content with your external assessment. You got it all loaded up, and you want to start doing your automated testing. You want to run the scan. So, automated testing. This is where the analyst or the person actually is clicking the scan button. So let's say we got everything defined in our burp sitemap, and we go do the active scan burp. And yeah, this is basically going to try and identify vulnerabilities. It's going to try and basically give us a lot of results. Sometimes it varies in time, but this is a part of the job. It's part of what we do. You want to make sure that, like I said earlier, you want to run the right tool for the job. The commercial tools, they kind of just blanket everything. But, like I said before, if you got something from like the OSINT with Joomla or WordPress or Drupal, there's custom tailored tools. So make sure you run their scanners as well, because they may enumerate something else that Burp or AccuSec or WebInspect may miss. Also keep in mind, with automated testing, your automated tools, you need to monitor them because they can miss things, they can break things, they can vary in time, take a long time, and they can cause false positives, and report false positives. So I'm not here to bash automated tools, I promise you that. I use them, I love them. But it's just something that we need to use as a staple point and a start point, not an end point. So that's just the whole premise with that. And this moves into our manual testing. This is like the meat and potatoes of this talk, right? So manual testing, there's 4 main questions I like to keep in mind when I'm doing my manual testing phase and portion. Essentially, I want to identify all areas of user input. These are injection points. So where are parameters, where are hidden values, where are things in these requests going back and forth that I can essentially fuzz and pass input to. I want to identify what is the purpose of this application, why is it created, what is it doing, what features does it offer, why did the developer create this, or what is this usability it's trying to portray, and how can I abuse them like an adversary would. So that's what you have to do. Essentially, and then you want to find all the systems, like the subdomain enumeration, the IP, the different things of that nature, and you want to find that unlinked content that automated tools may miss. So you really want to do all that work before you get into the manual testing phase. You always want to continue asking yourself, what happens if I try this? What is the response I'm going to get? Is it a new error message? Is it a different content link? Is it a different response, a status code? These are the things you got to keep in mind. And then we drill down into the further questions. Here's where we start to classify things as vulnerabilities, right? So we're like, all right, our input's being presented on the screen. Maybe I'm going to enter some bold tags in there and see if it actually bolds something when my output. Well, okay. From there, I'm actually going to try, if it does, I'm going to try and maybe do an XSS payload with an event handler or something of that nature, and maybe we can get an XSS to render in the browser. Then we'll also see, is my input being called upon or stored in the database? That's kind of hard sometimes, but if that's the case, try and do some SQL injection, pass some statements, try some different syntax, even some of the simple things like single tick, just see if you get a different response back. Does your input generate an action to an external service? So is the application trying to do something on behalf for you, like basically do a submission for you? Maybe sometimes you could do some server-side request forgery, and we're going to go over a really good example shortly. Does your input go, basically call upon a local file, or do you see it reaching out to another system? This could lead to LFI, RFI, and they're really interesting, and we'll give a good example of that too. File upload, a lot of applications offer file upload. Can we abuse that? Can we upload any file we want? Or maybe we capture it in our proxy, and it's a client-side check, and we can bypass the content type that it's trying to basically say is only allowed. Does our input go to another page? So a lot of times this happens, very common. A domain will say, all right, I have this resource and it'll redirect to my partner site. Well, if you don't have that resource whitelisted or blacklisted with domains, I can point that redirect to anything I want, maybe a malicious link, and I can craft something and send it on behalf and say, click this from Microsoft and, it's going to bad boy site. So redirects are a big thing too. And can we enumerate email addresses, basically extract email addresses while we're doing this in our assessment phases? Then we can take these email addresses and then create some phishing campaigns to target our scope. So essentially here, like Andrew touched on, I like to do everything in Burp. It's kind of like the bread and butter tool of external assessments with web apps. You want to take these different lists and open source because they basically can help you with your fuzzing. They can automate things when you're sending them to an intruder or repeater, whatever it may be. But you want to understand how your input's being leveraged and where to use it so you can identify those vulnerabilities we just discussed. What I like is in Burp Pro, it doesn't have a throttled intruder. But basically, let's say, for example, you're sending a request to repeater and you just kind of want to see, you're just manipulating things in input and you're fuzzing and you're passing it a couple times and you just see the response. Well, if you want to do that in an automated fashion, you can use intruder, and then that's when you can really leverage some of these great lists to maybe find those vulnerabilities. Now we're going to get into our Wreck-It Ralph phase, where we just like to go nuts. We're going beyond the automated tool, and we're going to go into the manual testing. So here's some real good use cases. We've got about 5 of them of how we use manual testing techniques to go beyond the tool. So feature abuse. Everyone's come across a contact us page or a feedback form in a web app. It's form-based usually, It's not a mail to where it's like, hey, send this email to this guy, okay. No, it's handled by the application, and it's, basically just saying, give me your name, your email, and then I'm going to send an email on behalf from the application, right? Well, commonly, the browser will play nice. It'll only give us a couple of fields. Well, if we capture this in a proxy, sometimes there's hidden parameters being passed client side. And we can manipulate these parameters, and then we can abuse these features. And how excited would you be if I could tell you that on your application, if you have this, that I could basically send an email from your CEO to anybody in your company through your website? Well, I'm excited at least. So here it is. Basically, it's a post request. We capture that, and it's a contact us page written in good old PHP. You getting feedback? Sorry. Written in good old PHP. And so basically, when we see it in the browser, we're able to manipulate the from line, or the to line, basically the Stephanie, which is the name. We're also able to make the message, which is basically, what's the contents in the email, and we're also able to supply our own email. Well, you'll see there's a site admin and a subject parameter behind the scenes, right? And we're capturing this in the proxy. We can manipulate this value. And I can send this from anybody to anybody with a different subject line to entice somebody to click on it as an email. And it's all coming from your site. So thanks. This is SMTP injection. This is a finding that an automated tool may not find, but a manual testing you will find. Then it's taking, say, example 2 here. Let's combine several low findings, right? So automated tools will find like, hey, there's no lockout. Maybe I found a username here. Potential, password complexity is low. And basically what we're doing here is we're taking several low findings and we're building them together to create something that could be potentially critical, like an account compromise. And what we're going to do is kind of cover that. So let's say, for example, your application has a password reset functionality, right? Depending on the error message it gives back, we may be able to say, if I supply this email address, is it saying email address not found? Is it saying this email was found? So is it a valid email or not? So I can sometimes get potential wins there. Depending on the login error message too, sometimes it'll say, invalid username and password. So you don't know if it was the bad password or username. Sometimes this says invalid username. So instead of giving me specifics, just be more generic. That's the better practice. Sometimes timing, so if you're looking at it, with Intruder, sometimes a successful login is 15 seconds in length. It takes a while to get in, while an invalid one is very short. User registration, this happens a lot, and it's kind of hard to control. You'll basically allow people to register for your site, and you'll say, all right, I'm going to do my username as Zack123. Well, it says that user already exists. So now I just know Zack123 is a username, right? So I'm going to definitely brute force the Zack123. And you could even run Intruder in Burp and try and enumerate further usernames. So this can kind of give you that treasure chest for brute force later. Various error messages. HTML source, sometimes developers will leave client-side comments in the code, so always look at that. And contact us, this is kind of funny. I had an application about a year ago. It was a contact us page, right? And it was saying, fill out all these forms, and then which admin do you want to send this to? So it told me Marianne, Joe, and Bob are the site admins. So now I know the site admin's usernames, and you bet I'm going to brute force that. You can find a lot of usernames through Google hacking, open source intelligence, like Andrew said, social media profiles, things like that. Document metadata sometimes has usernames and things of that nature too, that are on the sites. And sometimes the application just flat out tells you. There's applications I've seen, and I don't know what the purpose of this is, but the application in the bottom left corner will say, Joe was the last guy to log in. Well, thanks, you just told me Joe's a valid user. I don't know why you told me that, but okay. So we got a username, right? Let's send it to Burp's repeater, which is kind of like just send like one request, one request, one request. It's not automated, we just kind of send things. Let's say we manipulate the password field 5 times. We notice that no change in response. It hasn't said your account's locked out for Joe. Okay, let's try 10 times. Let's try 15. If there's no lockout, then game on. I can brute force and knock on the door of your login as many times as I want. And if you have basic authentication, there's no lockout feature built into that either. So keep that in mind. So then if you want to make it into an automated thing, you would send it to Burp's Intruder. And things, if we can find no account lockout, sometimes to thwart this, people will do CAPTCHAs. They'll do different things of that nature. They'll put in a policy for lockout, or they'll say, reach out to this site admin or whatever. But basically, if you lock down your logins, make sure you lock down all your logins, all of your different ways to get into the castle. I've seen it where a main login on a site is secure, it has policy in place, no automate, no lock, it definitely has lockouts, but their mobile interface or their API doesn't have a lockout. So people can get in with that same username into other logins, so keep that in mind. And weak passwords. We as humans are terrible with passwords. We are. It's just human nature, unfortunately. Whether it's now or in the past. I mean, I've been guilty of it too before I became in the security field. But passwords, sometimes they're the same as the username often. So sometimes there's variations of passwords. Sometimes people think they're tricky and they do keyboard walks, right? And they're like, oh, that's great. No, it's not. There's password lists out there that have keyboard walks in them. So keep that in mind. There's lots of great word lists out there, especially like Andrew said earlier, and with the sec lists and things like that. There's a great bunch. And even MySpace recently got compromised, and those creds probably will come out eventually. So maybe there'll be a word list for that, right? But consider basically, if you want to make a more targeted approach, there's a tool called Cool, and you could run that. It scrapes your site, and it kind of extracts like certain words to try and make a more tailored password list for you, or username list. You also want to research your targets. This is where you kind of go to a dark place a little bit, but this is true. Like if you enumerate that, John Doe is with the XYZ company, and then you find him on social media, and you find he has a loving passion for the Washington Redskins football team, like myself, then maybe you're going to make variations of passwords with the Redskins in it, or you find his daughter's name's Caroline. Unfortunately, this is the truth, and people do things they know and love as their passwords, so keep that in mind. Example 3. Hopefully I'm not putting you to sleep here. Example 3. Let's say you stumble upon a resource called Proxy.ASHX. Found this in a mapping application a couple months ago, and it was essentially there to give a functionality so if a domain doesn't play nice with the cross-origin resource sharing, the CORS policy, that you could still have it reach out to that domain. Well, that's cool and all, and it's a nice feature, I'm sure, for whoever wants to use it, but I'm going to try and abuse it, right? Because that's my job. I'm going to basically append a question mark to it. Maybe if that doesn't work, I would try a parameter and try and feed a URL. But essentially, all I did was append a question mark and try to get it to go to Google. Well, it loaded Google inside the domain. And that's pretty cool to me because it didn't leave the site and it loaded Google's content while I was still on the site. So that's pretty interesting. So we kind of have an open redirect here almost. And 2 ways you can misuse this is one, spear phishing. You could point it to a malicious link. You could obfuscate the link. You can do whatever you want, send it, craft it, and have somebody click on it, and they believe it because it's at a good domain, and they see the resource, and they don't know where it's going. Or, even cooler, we can bypass the firewall. So the application, essentially, this resource allowed us to make arbitrary TCP connections to systems, both external and internal. We tested it. And we could essentially try and map out everything behind the firewall and internal to the network just by making different connections. An example of this is essentially we leveraged it. We wrote a quick Python script with the request module, and we automated it to bypass the firewall and attempt to just try and connect to the internal network. And we just tried to map this out and looked at the results, and we looked at the 403s and the 200s and the 302s we got, rendered them, and we see, look here, something that we wouldn't see externally, but we're mapping out the internal network from an internet-facing resource in the site. And now I see that internal, you have this Cisco email security appliance, and I have the versioning and the login. It's pretty cool. So I'm actually touching things that I shouldn't be touching from the internet that are internal, all through just one resource that was built for usability but can be abused as a feature. All right?
All right, thanks, Zach. So I'm going to go into example 4, which is massaging file inclusion to code execution, which is a great way to impress chicks at bars, let me tell you. That's how I do it. So here we are. So file inclusion vulnerabilities, if you're not familiar, we kind of mentioned it a little bit earlier. So it's like you're loading some either local resource or remote resource, and it can be interpreted different ways by the application. You might get it to actually be interpreted and run code. Example would be like a PHP include, or it might just be catted to the screen, echoed to the screen. Example would be like a PHP echo. So essentially, with that, you have different things you can do. You might just be able to read files. You might be able to actually execute code. You'll play with it later to figure this out. And LFIs require a little more work than RFIs. So LFIs, you got to kind of have to shovel your input into a file and include that file. Maybe you can get your input into a file upload. Maybe you can get your input into a log file, and you want to include that file, and your input's generally code that you want to run. RFIs are a whole lot easier, usually, because you can just point it back to a resource you control and provide it code. And this is a good example because your automated tool may find you LFI, Burp will find you LFI, Kinetics will find you LFI or RFI, but they don't really like massage that to a web shell for you and let you go further. So I wanted to kind of walk people through this because it might be new. So here's a real example. I took over a pretty big organization with this bug we're walking through right now. We started out doing our reconnaissance, and I was starting mapping. I stumbled upon unlinked resource debug.php on this application. It was actually in the RAF list. That's one of the things that RAF list will check for. And it gave me an HTTP 200OK and a blank screen. Now, the likelihood of your automated tool finding this is probably low unless you did that manual unlinked content enumeration. But at this point, since it's PHP, there was no client-side code shown to the screen. There's not a whole lot you can do, and your automated tool is generally just going to completely stop right here. Cool, 200OK, have a nice day. The next step, as we talked about, is trying to figure out all of our injection points, all of our areas of input. So in my head, I'm thinking, great, now I've got this debug PHP, blank screen, big whoop. What does it do? I actually think I went to lunch, came back, and was like, oh, let me check parameters. So I ran it through a parameter list in Burp's Intruder, and they actually have a built-in list in Burp's Intruder, and essentially you can run through and see all the common parameters. And I was getting the same response length back of 193, I believe, and it was just that blank screen. All of a sudden, when I got page parameter, it gave me a response length of 693 or something, 632. And as I put it in my browser, I saw a PHP warning. And this is where I'm getting really freaking excited because it's basically telling me it's trying to include my input with a PHP include function. So I know that I can potentially get this some code execution here. So the next step is, you can try local etc password, right? See if you can get there. That's cool, it did that. And now I'm going to try to see, can it touch me? Can I point it to an external resource and give it code? So that's exactly what I did. So in step one there, you see the request, and I'm pointing it to just an external URL that I'm going to put some code at. Step two, we have my Python simple HTTP server. Just a quick way as a pen tester to create a little web server to get some stuff from you. And I'm just having it grab 1.php, which is just the file at the top, that little one-liner running an ID command. And in the third bullet there, you actually see the result. data. I'm actually running commands in the box, which is pretty cool. And this is just one of those steps that you wouldn't have necessarily found if you pointed burp, accu. I mean, I've actually in a lab I have the code I can put. I think it's online, and you can run every automated scanner you want at it. It's just not going to find it because you don't point it to. It doesn't know this page resource, that kind of thing. So in real life, this is the final step. It was sad. It was awesome for us, bad for the customer, but it was running on a Windows system as system. So that's crazy, awesome though. So what we did, I just recreated in a lab for this example here, which is why it's a Linux. But we just wrote a little Python web shell. Actually, it was just using the request module, which we really love. And it was just making web requests in the background. So I'm grabbing my input right there via raw input. So PWD, I'm taking that and I'm putting it inside of the PHP code and I'm just shoveling it to the server to run. And it basically runs it for me. It automates that command, the previous slide, in what feels like a shell, but really it's just making web requests out there. So at this point, you wget over like Meterpreter, the temp directory, and run that and get a better shell. But this is just a good way to kind of like automate that. And maybe the customer doesn't want you to put anything on the box, right? And you have to live with this, and this could be like the way you have to live with this, depending on the rules of engagement. The last example here is email spoofing. So I think the perception, at least, before I started doing this, my perception was email couldn't be spoofed as bad as it can be. And I was really, really shocked at how easy email spoofing occurs. So the reality is, without certain defenses set up, SPF, DMARC, DKIM, some DNS text records and such, you can do a lot of email spoofing. There's some statistics there that basically state, hey, phishing works. So I don't think I have to convince anybody here, but we're going to walk through some easy ways to test for mail servers for spoofing vulnerabilities. And I'm actually going to show a real-world example with Google Apps for Work, which is actually really bad. But so step one, here's what you do. You try to find the mail servers for the target domain. Host in Linux tells you the mail server's right there. Step two, make a connection to the mail server. Step three, we're going to forge the headers. So you can actually see there that's me manually typing in the headers and forging the headers. And then step four, we're actually forging the email. typing data, putting in all the email headers here, subject line, hey guys, take a look, this is how you spoof email. And the period there at the end specifies that the email's over, you hit enter, and it sends it, hopefully. So this is actually with Google Apps for Work. You might notice that the Google is the mail server, and that's what it looks like in your inbox. Doesn't say it's been spoofed, doesn't have the little like weird, any indication other than the one I made, CEO fake email at primalsecurity.net. Pretty scary stuff, and that will work, tricking users if they see that kind of thing. It doesn't have to be the same domain, so this was primalsecurity.net. It could be, President of the United States, POTUS, urgent president stuff, get to the chopper. Point here is, you'd be surprised at how often you can spoof stuff. Things in default configuration. I was always, before I started doing pen testing, I was like, nobody uses password as password. Like I was working in DoD environment where you're forced to use 16 characters, crazy stuff. And then as I started testing that set environments, the web apps and stuff don't follow the same rules, and they're very weak. But this is just another example of that. Please, you definitely want to test it even if you have the perception it's secure. So here's another slightly, so we communicated that to customer, they fix it, right? Now, how can you bypass that? Well, this is an example of a bypass. I sent this email here you see with Outlook client. That's from a random Gmail account, just random Gmail. Do you see any signs that it's a random Gmail? Right off the bat, what did I do? If you send email to Gmail in the web client, it forces you to play nice. If you send email from Gmail with Python, you can do a little more tricks. You can change the name field, which is the only thing that Outlook is parsing here in the preview pane. So as you can see, I just changed the name to help desk support, but in reality, it's just some random Gmail account I created, and I'm sending it via Python. And you can see there, that's a pretty believable link. If I sent that to a client, I'm going to have a very high success rate. Now, in theory, there are some telltale signs. They could have hit the reply all button and see the actual Gmail or inspect the headers, but I don't think a lot of users are doing that. But in any event, this is a pretty scary thing, and I actually just used a legitimate Gmail account. We actually have the code. We'll put it in a blog post. I think we already did. Yeah. We have the code for doing that, and just basically it's Python script to send email through Gmail.
Yeah, it's on the BreakPoint website.
So now a little bit more about the Google Apps for Work thing. So Google Apps for Work is what I used, what a lot of companies use. It's actually really nice. But out of the box, it's very, very, very vulnerable to email spoofing. And they don't do a whole lot to tell you what to do and hold your hand to fix it. In fact, everybody that I've seen using Google Apps for Work is completely vulnerable to being spoofing their target domain. I've seen very few people that configure this stuff. So essentially what you have to do is configure like SPF, DMARC, DKIM, these are DNX text records and stuff, and Google will help you do that, but you got to call them. You got to work with your hosting provider, set the appropriate DNS records, and people that are using Google Apps for Work tend to not have a whole lot of infrastructure yet, and they may have not took the time to do these steps. The previous emails I used, so that Primal Security, I basically just telnetted right to it and sent it without any authentication because I didn't have the right text records set up and security in Google, which is really scary. I think that you'd be surprised if you find somebody using Google for their mail services, odds are you can send email through them and spoof them like crazy. The solution is to configure the proper text records, and you can configure that in Google's security as well as your text records. But again, this is just one example. This lives in many other places, many other services, and very few people, in my experience, configure that properly. So now reporting. This is my favorite part of every assessment. I just love the shell stuff. That's boring. This is what I live for, right? You can sense
pays for, right? That's essentially.
You can sense the sarcasm, but as Zack said, it is really important to the customer. Yeah. Obviously, you're not going to convey your results if you don't have a good report. So here's what we do to add a little more value beyond like your printed out Nessus or Burp or Reconnaissance with the hand breaking through the glass. So we leverage Markdown. We really like it. If you've ever been to GitHub, you can see it's really clean. It looks just like that. It's HTML shorthand, essentially. You can do very simple syntax, and it converts to HTML. It's like Sublime text editor. There's a common findings database run by Mubix, which is really nice, all in Markdown format, and they have got vulnerability write-ups for you. So if you're new to this stuff, it's actually a good place to go. What does a pen test report look like? How do you write up vulnerabilities? You can actually go there and look at the templates. The one important thing with this is understand that this is for your customer. You're communicating to your customers. Make sure you understand your audience. I've not met a customer that just wants a web inspect report handed to them or a Nessus report, but it could happen. They may just want a spreadsheet. So understand your customer's needs and go from there. Depending on your rules of engagement, you might want to show how you exploited it, but maybe you couldn't exploit it, right? Maybe they said they want a vuln assessment. They're calling it a pen test, but it's really a vuln assessment. They don't want you to exploit it. So put an attacker scenario section in there and say how you could have exploited it. Maybe do a lab and show like, here's what could happen if you don't fix this, help drive the points home. We also like to put pictures in there and screenshots to help the tech guys and include the detailed steps we took to get this finding, how it all put together. But then going back to understand your audience, don't forget the managers. If that is where the report's going, make sure that you provide the appropriate detail for them. They're not going to care about the shell. They're not going to care about all these tech details that we get excited about as testers. They're going to care about, green and red and understanding, from a higher level how they can control risk. The last bit here is offering remediation support. We really like this because we find that when we give some remediation advice, our customers go in a different direction. They fix one instance that we showed them. And XSS, for example, they fixed the script alert script, they blacklisted it, and then we can do JavaScript event handlers and bypass the fix. Well, that's just an example, but the point is remediation testing helps to make sure that they've truly addressed the problem and not just an instance of the problem. And again, be creative with that, kind of go through your normal fuzzing process. And this can lead to additional testing and a stronger relationship with your customer and adds value beyond that, automated tool. We're finishing up here, so these are the useful links for training. Cybrary is really good. A lot of free stuff there, definitely check it out. VulnHub is great. You can get a bunch of CTF VMs and the such challenge VMs to practice on, because you can't usually do this in real life without some practice. Past CTF write-ups are great, even joining a CTF. I have a lot of people that don't do this work and they want to do CTFs. I mean, RVAsec's got a great one here, and just join one. They usually don't have to be a elite hacker to go play in a CTF. Pentester Labs are another good resource, and there's a bunch of talks and books here I won't go through, but these are the stuff that I've read and gotten some value out of it, and just figured I'd share with you guys. And that's it. You can feel free to come up and talk to us after the talk here. I think Chris might be giving something quick here, but here's our site and email and Twitter handle if you have any questions.
Thanks, everybody.
Thanks.